Hey everyone, welcome back to another lesson in Math 2. Last time we talked about the idea of imaginary numbers and what an imaginary number was. Remember that taking the square root of a negative number in a real sense doesn't make sense. Any number that we know of times itself can't give us a negative number. And so we define a number where you square it and you end up with a negative number. We call that the imaginary unit. So you remember that the imaginary unit is that the square root of -1 is equal to I. That's what we call it. And as a result of that, we know that I squared is going to be -1 because when I square both sides of this top equation, the square root and the square are inverse operations, so those reduce each other, they cancel each other out, and you're left with -1, and on this side you have I squared, so I squared equals -1. So I told you last time that that's very important. Then we talked about the idea of adding and subtracting and multiplying complex numbers, and those complex numbers looked a lot like binomials. When we were multiplying binomials from first semester, adding, subtracting different polynomials, binomials, operations with complex numbers are the same rules. There's just one additional thing that you need to remember, and it actually makes the process come out to be very simple, because whenever you see a squared or an I squared, you can replace it with -1. So with that said, go ahead and do these two practice problems, and just for good practice. And once you're done with them, come back and watch how to do them the correct way, and hopefully your way is the correct way as well. All right, for number one, we have 6 plus 5i minus 4 minus 7i plus -5 plus 10i. And so we want to just simplify this. So we're basically adding and subtracting binomials here with imaginary numbers. So we put the 1 out front here, and we distribute the 1 into each one of these. In this case, it's a -1. In this case, it's a +1. And so when we do that, we end up with 6 plus 5i minus 4 plus 7i minus 5 plus 10i. And then from there, we can combine like terms. We add the constants here. We have the 6, the -4, and the -5. That's going to be -3. And then we have the 5i, the 7i, and the 10i. That's going to be 22i. And so that is as simple as it can get. Notice when we're talking about terms with variables in it, expressions with variables in it, normally we have the variable go first to put it in standard form. But in this case, if we're talking about imaginary numbers, we put the real number first and then the imaginary unit next. Okay, so 3 plus 22i is correct. All right, for number two, we have 5 plus 3i and then times 5 minus 3i. So remember, when we rewrite this, we expand it. We say 5 times 5 minus 3i plus 3i times 5 minus 3i, just like multiplying polynomials. Then we distribute into each of those. And so we end up with 25 minus 15i plus 15i minus 9i squared. Now we can go ahead and combine like terms. We got -15i and 15i. That's actually going to cancel each other out because that turns into 0. And we're left with 25 minus 9i squared. But then we can go one step further, because remember that I squared is -1, so we can replace it with -1. And so we can see now that we can keep going. So we have 25 plus 9, and then 25 plus 9 is 34. And so right here is an interesting idea, and that is that I can work with imaginary numbers. We talked about this a little bit last time. I can work with imaginary numbers in such a way, if I do certain things, I end up with a real number. There's no i's left over here. And so if we can somehow manipulate expressions that have imaginary numbers in them to make it so that the result is only real numbers, that makes our relationships with math doable. We can work with these imaginary numbers to produce things that are real, okay? And that's important. Now notice what happened here that produced the real number. Notice and I wonder if this is true all the time, that what I was multiplying here had the same two terms, but different signs, okay? And so that is what we're getting into next. So go ahead and take some notes on this. This is important. The conjugate of a binomial. The conjugate of a binomial. What does a conjugate mean? Now we have the English idea of conjugate, the language idea of conjugates, but we're talking about math conjugates here. So a conjugate is a binomial whose first term is the same and whose second term has opposite signs as a given binomial. So for example, if I have a binomial that says 9x minus 5, what would the conjugate be? It's just a term. Don't get overwhelmed with it. We're not doing math here. We're just identifying the idea of a conjugate. The conjugate, remember, of a binomial has the first term the same and the second term with opposite signs. So the first term in this case is 9x. So the conjugate will have 9x. The second term in this binomial is negative 5. So the conjugate's second term will be positive 5 because the second term has opposite signs. So the conjugate here is going to be 9x plus 5. So the original one was 9x minus 5. The conjugate's 9x plus 5. Let me do another one here just so we can see the relationship. If I said 3x plus 7, then the conjugate of, oops, can't see that. Then the conjugate of that would be 3x minus 7. The first term's the same. The second term's the same. It just has a different sign. That's all there is to it. Okay, that's what a conjugate is. Now, with that said, let's do some practice on this. I want you to multiply the complex number by its conjugate. Multiply the complex number by its conjugate, okay? So just looking at the first one here, number 6, I know it seems like we skipped a few problems here, but number 6, we have 2 minus 9i. So I'll get you started. What is the conjugate? The conjugate has the same first term, so it's a 2, and the second term has different signs. So instead of minus 9i, it's going to say plus 9i. Okay, so we want to multiply the complex number by its conjugate. So that's the setup. That's what we're trying to do here. So go ahead and pause the video. You do this problem and then come back and see how you did. All right, for this problem, we got 2 times 2 plus 9i, we're expanding, minus 9i times 2 plus 9i. And then we distribute, so 2 times 2 is 4, 2 times 9i is 18i. And then negative 9i times 2 is negative 18i, and negative 9i times 9i is negative 81i squared. Combining like terms, you can see that the 18i and the negative 18i are going to cancel each other out. We're left with 4, and then minus 81, and then I'm going to skip a step here. I squared, we can replace with negative 1. And I'm going to want to see that for sure. I want to see that you recognize that I squared is negative 1. Now we'll simplify from here. We get 4 plus 81, which is 85. And so you can see again, when I multiplied these two things, I ended up with a nice, clean, real number. Well, why is that? What is happening? The reason that's happening is because we are kind of multiplying a difference of squares. Remember when we multiply difference of squares, two things that have the same values, just different signs in the middle, that middle term is always going to cancel each other out. So the 18i and the negative 18i in this case canceled each other out. And then the first term is a real number because it's 2 times 2. The last term has an I squared in it, so that I squared becomes a real number, negative 1, and then I can simplify it all to a nice real number, okay? For number 7, well, we have negative 5 plus 2i. What is its conjugate? Its conjugate would be negative 5 minus 2i. And then when we multiply that out, negative 5 times negative 5 minus 2i plus 2i times negative 5 minus 2i. And then multiply, we got 25 plus 10i minus 10i minus 4i squared. And so we can see that this is all starting to play out nicely. The 10i and the negative 10i are going to reduce each other. We're left with the 25, and then we have the negative 4 times I squared. So I squared is negative 1. So this becomes 25 plus 4, which is 29. Again, a nice, clean, real number. okay? All right, so just double checking my work here, 85 and 29. Now, why does this matter? Well, you're going to see in the next slide why this is so important. We're going to be using this idea of multiplying by conjugates to simplify things that seem really complicated, but they're actually not that complicated, okay? So what do you notice? We kind of already answered this. What do you notice when you multiply conjugates of complex numbers? Well, you should notice that you end up with a real answer, okay? The answer, the result is always a real number. All right, let's go ahead and take a look at the next slide. I definitely want to have you guys write these down as notes. Remember, it's not acceptable to have a radical in the denominator. We talked about that when we first started talking about radical expressions in general. And the example I'm giving you is this. If I were to ask you to simplify 8 over radical 2, well, this is unacceptable because the radical is in the denominator. And so how do we get rid of the radical in the denominator? Remember, we got 8 over radical 2. The way we get rid of that is by multiplying by the magic number 1. We multiply by radical 2 over radical 2. Because radical 2 over radical 2, as I talk over the bell, is 1. So we're not changing the value, we're just changing the way it looks. So when I multiply this, I end up with 8 radical 2 on the top. We multiply the things that we can multiply together. This is outside, this is inside the radical. We can't multiply those. But on the bottom, the radical 2 times the radical 2, we can multiply that. That becomes radical 4. And we know what the square root of 4 is. The square root of 4 is just 2. And then we can reduce the 8 and the 2 because those are both real numbers, or both nice clean whole numbers, non-radicals. We end up with 4 radical 2. And so the point is, we can manipulate this expression, this 8 over radical 2, to get rid of the radical on the bottom. The radical on the bottom is not acceptable. Well, how does that matter? What does that matter for what we've been talking about the last couple days? Well, it's very important. Watch what happens here. Okay, what is wrong? What is wrong with the expression 4 minus 5i over 2 plus 3i? There's a major problem with that. And it has to do with the idea of radicals. Remember what I is. Remember, I is the square root of negative 1. So if I were to substitute the square root of negative 1 into I should have done it up here as well, just so you can see it. But I would have ended up with a radical in the denominator, just like I have a radical here. I cannot have a radical in the denominator. That's not acceptable. So by having an I in the denominator, that's not acceptable either because I is a radical. It's a special kind of radical. So how do I fix that? How do I make it all better? How do I make it so that the radical disappears? How can I fix this? Okay, so let's go ahead and take a look at how we approach this. Okay, we've got 4 minus 5i over 2 plus 3i. Well, I'm not allowed to have the imaginary number, the radical, in the denominator. So I have to somehow get rid of it. Now, some students might say, well, just cancel out the i's. You can't do that because you have a sum here that has to be dealt with on top of that, and we can't combine it like that. But from the previous slide, we discovered that when you multiply conjugates of complex numbers, multiply conjugates of numbers or expressions with imaginary numbers in it, the imaginary part goes away and you're left with just a real expression, a real number. Now, I don't want to multiply by the conjugate of the top because I'm not trying to cancel out the imaginary on the top. I'm not trying to get rid of that. I'm trying to get rid of the imaginary on the bottom. So let's multiply the bottom by its conjugate. We'd multiply by 2 minus 3i. Now, I can't just multiply the bottom by 2 minus 3i. In order to keep this value the same, I have to do the same thing on top. Just like when we were talking about the radical expressions here, we had to multiply by rad 2 over rad 2. We had to multiply by the magic number 1. So whatever we multiply on the bottom, we need to make sure that we're doing the same thing on top. That way it reduces to 1, okay? So I multiplied by the conjugate here because I know that I'm going to end up with a real number when I multiply by conjugates, okay? So now let me rewrite this. Let's do the top. We end up with 4 minus 5i times 2 minus 3i. And then on the bottom, we end up with 2 plus 3i times 2 minus 3i. Now, You can expand all this if you need to. You'll expand it to say 4 times 2 minus 3i minus 5i times 2 minus 3i. But we should be getting to the point now where we can recognize the FOIL method a little bit quicker. Remember, we just want to multiply the 4 times both of the second terms. We want to multiply the negative 5 times both of the second terms. So we're going to multiply the 4. Let's see, 4 times 2 is 8. 4 times negative 3i is negative 12i. Negative 5i times 2 is negative 10i. And then negative 5 times negative 3i is positive 6i squared. So there, we did the top, we did the numerator, okay? And it would be the same if I expanded it all out, but just to reduce the amount of work on our paper, we should be able to quickly shortcut that a little bit by now. From here, multiplying the bottoms, the 2 times the 2 is going to be 4. The 2 times the negative 3i is going to be negative 6i. The 3i times the 2, that's going to be positive 6i. And then the 3i times the negative 3i becomes negative 9i squared. And then from here, it just becomes a result or a matter of simplifying this. So the negative 12i and the negative 10i can be combined. Negative 12i minus 10i is negative 22i. And then the 6i squared, I'm going to rewrite that as plus 6 times negative 1, just like I did on the previous slide. And then on the bottom, we'll do the same thing. We've got 4, and then the negative 6i plus 6i are going to cancel each other out. And then we have minus 9 times negative 1. And so now on the bottom, we only have real numbers. And so that should simplify nicely. Let's go ahead and keep simplifying here. We end up with, on the top, 8 minus 22i minus 6. And on the bottom, we end up with 4 plus 9. And then I'll just write it next to it. 8 minus 6 is going to be 2. And then minus 22i. And then all over 4 plus 9 is 13. Now that is the end result. We're going to talk about reducing a little bit later. If we can reduce all of this by a common factor, we should do that. And notice the common factor on the top is 2, but we don't have a common factor of 2 on the bottom, so we can't reduce that any more than we already have. But anyways, our simplified form of this is now 2 minus 22i, and the reason is because the 13, my camera keeps moving on me, because the 13 on the bottom is a real answer instead of having an imaginary unit in it, which means we don't have any radicals on the bottom, which is exactly what we want. And what in the world did I just do with this problem? I screwed something up pretty badly. Where did I make a mistake? I see where I made the mistake way, way back here. I got to fix this. Negative 5i times negative 3i. I put, I don't know how I got this, but I got 6i squared. Negative 5 times negative 3 is going to be 15, positive 15i squared. And then from here, we've got positive 15 times negative 1. And then that's going to turn into negative 15. Boy, I messed that up. And then simplifying that, 8 minus 15 is going to be negative 7. Negative 7. Woo! That's why we always check our work, right? Anyway, so that's how we do that. Multiplying the denominator by its conjugate will get rid of that imaginary unit, okay? All right, for number 8, you guys go ahead and try and do this one on your own, and then come back and push play to see if you got it right. All right, for number 8, we have 5i over 2 plus 3i. Well, notice this looks a little different. We don't have a binomial on top and a binomial on the bottom. We do have a binomial on the bottom only. But where's the problem? The problem is that we have an I in the denominator. That's not okay. So how do I get rid of that? Well, I multiplied the denominator by its conjugate. So it's going to be 2 minus 3i. But when I do that, I have to do that with the top so that I'm multiplying by just 1. So now I'm going to just put parentheses around all of this so I can see it. Okay. Now the top is pretty simple. We have a monomial times a binomial. So all I have to do there is distribute the 5i into both of those. So that's going to clean up nicely. That's going to end up being 10i minus 15i squared. And then on the bottom, we'll FOIL that all out. So 2 times 2 is going to end up being 4. And then 2 times negative 3i is negative 6i. And then the 3i times the 2 is positive 6i. And then the 3i times the negative 3i is negative 9i squared. Got to extend my line there. Okay. Now from here, we'll simplify. The top, I can't combine them because you have an I and I squared, but I can simplify it. It becomes 10i minus 15 times negative 1. On the bottom, we'll do the same thing, but we notice that the negative 6i and the 6i cancel each other out. So we're left with 4 minus 9 times negative 1. And then that'll simplify. We've got 10i plus 15 over 4 plus 9. Now, if you can do all this in your head, you could just say negative 9 times negative 1 is positive 9. 4 plus 9 is just 13 if you need to. So you end up with 10i plus 15 over 13 as an answer. Now, this isn't written in the normal complex form. Remember, the whole number, the real number, goes first, and the complex number goes second. So it would be 15 plus 10i over 13. And since that can't be reduced, there's no common factors out of all three of those terms, the 15, the 10i, and the 13, we're just going to leave it like that. So we end up with, double check my work, 10i plus 15 over 13. Don't worry about separating that. That's not the important thing here, okay? This is sufficient as far as your answer is concerned. All right, with that said, that's how you deal with imaginary numbers in the denominator, right? We have to multiply by the conjugate of the denominator on both the top and the bottom, and then simplify like we always have, multiplying binomials, changing the I squared into negative 1, and then just simplifying it as far as we can from there. With that said, if you have any questions, please comment below, and I will talk to you all later.